ladies, gents, and everyones. It is Thursday, June 23rd, and we're here to talk about this week's space and astronomy news. NASA attempted 3 times to complete the wet dress rehearsal test for Artemis I back in April, but was forced to roll it back to the vehicle assembly building for fixes. So I definitely had my fingers crossed as the rocket came back to the launch pad this month and attempted its 4th wet dress rehearsal test, culminating in the propellant loading and countdown test on Monday. The plan was to do the test all the way down to T-9 seconds, but they actually ended up stopping it at T-29 seconds. And getting even that far was not easy. A hydrogen leak was discovered in the tail service mast umbilical that would have halted the process if this had been a real launch. But in order to get as much data as possible from this test, NASA actually basically just told the computers to ignore the leak so they could go ahead and get the rest of the countdown test practiced. At a media briefing on Tuesday, NASA said that they basically got 90% of where they needed to be with this test, and there were still a few unaccomplished items, and they were evaluating whether or not they'd need to do the test again. However, a NASA spokesperson today confirmed that they will not be planning another wet dress rehearsal test for Artemis I, which means that the next time we see this rocket out on the launch pad will be for the real deal. Now, there's no target date for launch yet, but it could be as early as late August. These types of woes and delays have long plagued NASA's Space Launch System, which is an integral part of the Artemis program, which aims to return humans to the moon sometime this decade. The first 3 missions of the program are Artemis I, which is an uncrewed test mission around the moon, and Artemis II, which is a crewed test mission around the moon, and then Artemis III, which will actually land crew on the moon. However, details of future missions, including program goals like establishing a permanent lunar base, have been scarce. Well, this week, reporters over at Ars Technica got a hold of leaked NASA internal plans for the Artemis missions. This included revised schedules, likely created because the baseline plan was basically not going to happen within budget and on schedule, and these revised schedules are surprisingly slow and spread out. For example, the earliest date for that lunar surface base is 2034, which for reference is 7 years after China's stated date of creating a lunar research station. A lot of this slow pace is driven by the very high per-launch cost of the SLS and development delays for its Block 1B variant. The schedules do not include any reference to potential commercial options, which might be much cheaper and more efficient, although none are currently available yet. The revised schedule focuses heavily on the next 10 years in building the Lunar Gateway, which is an orbital station around the moon that will help bridge the gap so that SLS can get from Earth to the moon and back. Well, these sorts of long-term plans are always subject to change, and a NASA spokesperson said that these sort of contingency plans are just a prudent part of programmatic planning. It's disappointing news for those of us hoping to see progress in human space exploration. Microlensing is not really tiny glasses. It's actually a technique that takes advantage of the properties of general relativity to observe objects that we might not be able to otherwise observe. Basically, if the alignment between the observer, us, the foreground object, or the lens, and a background object, or the source, is just right, then the lens will cause the source to appear brighter. So even though we can't see the lens, we know that it's there. And as we move in and out of this perfect alignment, the light from the source will kind of undergo a characteristic peak, and from these measurements, we can infer things about the foreground object. Microlensing can be used to detect exoplanets, and because of its sensitivity, we can actually use it to detect even low-mass terrestrial type exoplanets and those that are very far away from us. We might then hope to detect potentially habitable exoplanets using this method. Which leads to the question, could other civilizations looking at us detect the Earth via microlensing? This idea of mutual detectability is a promising avenue in the search for intelligent extraterrestrial life. And knowing where other civilizations might be able to detect us can help us narrow in our search areas. So a paper released this week as a preprint seeks to identify the so-called Earth microlensing zone, that is, regions of the galaxy where other civilizations might be able to see the Earth via microlensing. They found that overall the Earth is actually quite dark to such observations, but there are some most probable regions, mostly along the galactic plane. Interestingly, there are regions where the Earth microlensing zone overlaps the Earth transit zone, which is the same concept but for detection via transit. And so these regions might be some of the most promising targeted SETI searches. Planets aren't the only objects that we can detect using microlensing. Recently, a microlensing target was followed up with the Hubble Space Telescope, and the scientists were able to determine that the mass of the object was consistent with being a compact object, that is, a neutron star or a black hole. In fact, there were 2 teams doing this, and one team found a mass that was consistent with only a black hole, and one team found a result that was consistent with a neutron star or a black hole. Which is exciting because black holes are, well, black. They're really difficult to detect, and so far we've only been able to do it in binary systems where we can see the effect of the stellar mass black hole on its companion. So this was possibly the first ever lone black hole. And another team of scientists just released their observations of this object in X-rays. They were able to place upper limits on the X-ray flux from this object, and that flux was consistent with a black hole and not with a neutron star. The X-rays would be coming from interstellar medium being accreted onto the black hole. So yeah, we really caught a black hole just drifting along on its quiet, dark way through space. This past Tuesday was the summer solstice here in the northern hemisphere. This is the longest day of the year thanks to the Earth's axial tilt. With these longer days come higher temperatures, and in many places in the US, it is wildfire season. One brush fire, the Contreras Fire, started burning on June 11th in the Tohono O'odham Nation near southern Arizona. And as the fire spread, it started to approach the Kitt Peak National Observatory, which had to be shut down and evacuated last Wednesday. Kitt Peak is home to 20 optical and 2 radio telescopes, one of the largest arrays in the world. As the fire continued to spread last Thursday, firefighting crews cut lines in the trees and brush to protect the ridge, the individual domes, critical infrastructure, and some flammable propane tanks. Luckily, thanks to a huge effort by the firefighting team, the worst of the fire has passed by the observatory and there does not appear to be any visible damage to the exterior of the telescopes, though some of the non-science buildings were lost. Of course, the protection of the personnel is the most important thing, and this fire is still continuing, although it's at about 50% contained now. But these are really important scientific instruments, and so it's really great to see that they are still standing. As non-firefighting teams are able to re-access the site in the coming days and weeks, they will be doing damage assessment and will get a better picture of just what the state of the observatory is. Y'all, we are less than 3 weeks away from JWST images, so yay! Well, that's all I have for you this week. Thank you so much for joining me, and I will see you again next week. Have a good one. Bye!